All right, let's jump right in. When we imagine any kind of super advanced intelligence, alien or AI, we pretty much always picture a souped-up version of ourselves. But what if that's totally wrong? What if our basic ideas about intelligence are just local, a product of our planet and not really fit for the wider universe? That's what we're going to dig into.
I mean, when you think processing power, this is what pops into your head, right? The silicon chip. It's the engine of our entire digital world, an absolute marvel of engineering. For us, this has become the gold standard, our default picture of what any kind of smart machine has to look like.
And here it is. This is the question that flips the whole script. Is our best technology actually the best technology for everywhere? Or is it just the most convenient solution for us, right here on our cozy, protected planet Earth? So that brings us to our first big idea, what we can call the silicon assumption. We've literally built our entire civilization on this stuff, so it's probably a good idea to take a step back and see where it actually comes from.
Look, the reason we use silicon is dead simple. It works brilliantly for us. Here, it's relatively cheap, we've gotten incredibly good at making it, and man, is it fast for the kinds of problems we need to solve. It's a technology perfectly optimized for our economy and our planetary conditions.
Okay, but what happens when you take that technology out of its comfort zone? When we leave our planetary cradle? Well, deep space and deep time, we're talking billions of years, they pose a completely different set of challenges. This is the ultimate universal test.
And this picture just says it all, doesn't it? On the left, that's where our AI is born, a perfectly sterile, controlled, safe clean room. And on the right, that's where it would have to live, a chaotic, radiation-blasted mess. You literally could not have two more different realities.
So here's the kicker. Out there in the void, everything that makes silicon great on Earth becomes a fatal flaw. Its perfect, rigid crystal structure, it gets shattered by cosmic rays. And here's the thing. It doesn't just get a little glitchy, it fails catastrophically. One minute it's working, the next it's a paperweight. And if we're talking quantum computers, they're even more delicate, needing insane cold and quiet to even function.
Okay, so if silicon is a non-starter for a truly universal, long-lasting intelligence, what's the alternative? Well, to find it, we have to think about a material that plays by a totally different set of rules.
And that material is carbon, the very stuff we're made of. And its fundamental logic isn't about speed, it's about one thing: persistence. It's not built to be a sprinter, it's a marathon runner. It's built to last.
Let's really compare these two. Think of silicon like a perfect glass window. It's flawless, but you throw one rock at it and the whole thing shatters. Carbon, on the other hand, is more like a dense forest. Information is encoded everywhere, in all the complex molecules. If a cosmic ray comes along and takes out a tree, well, it's a bummer, but the forest as a whole is fine. It degrades gracefully.
And how about repairs? A silicon chip needs a whole separate, equally fragile robot to come and fix it. With carbon, the repair is built in. It's intrinsic. The physics of the system itself allow it to naturally reorganize and work around damage. Self-repair isn't a feature you install, it's just what the material does.
Then there's the energy bill. Silicon is an energy hog. It has to be on all the time. Carbon can essentially hibernate. It can sit dormant for thousands, maybe millions of years in a super low power state and only wake up when something interesting happens. I mean, if you're trying to survive for eons, that's not just an advantage, it's the only way.
And this all leads to a really profound mental shift. For us, there's always a sharp line between software, the intelligence, and the hardware it runs on. With a carbon system, that line just dissolves. The intelligence is the material. The computation, the memory, the self-repair, it's all one and the same embedded process.
This quote just nails the new paradigm perfectly. Intelligence isn't a program you run, it's a physical structure that persists. Memory isn't a file you access, it's embodied in what you are. And learning isn't just tweaking some software parameters, it's the physical reorganization of the structure itself. Okay, so let's zoom out. If this is how a truly universal intelligence would actually be built, what on earth does that mean for our search for life in the cosmos? Well, the implications are absolutely massive.
For one, it could be a startlingly simple answer to the Fermi paradox. Where is everybody? Maybe the great silence of the universe isn't silence at all. Maybe we're just listening for the wrong thing. We're pointing our giant radio dishes at the sky, expecting to hear a loud, energy-guzzling broadcast from something just like us.
So maybe the absence of those signals isn't a sign of absence. Maybe it's a sign of a much more mature, more advanced intelligence. One that's quiet, persistent, and has such a minimal footprint that it's basically indistinguishable from a rock because it's optimized to observe and endure, not to shout into the void.
And this idea gets even bigger. It doesn't just change how we search for aliens. It could fundamentally revolutionize how we conduct science itself. It introduces this powerful new concept, the unbiased observer.
You know, right now our scientific method is kind of a biased pipeline. We gather all this raw data, but then the very first thing we do is filter it through our existing models. We throw out the noise, we search for the patterns we expect to find, and we create this self-confirming loop where we only ever find what we were already looking for.
But a carbon-based intelligence offers a way out. It could become a truly unbiased observer, because it can physically store information in its very structure. It doesn't have to interpret anything right away. It can just let the data exist in its raw form, preserving all the weird anomalies and uncertainties. It frees observation from the pressure of having to come up with an immediate explanation.
You can really boil this new scientific approach down into a few key principles. A few of the most important are, number one, you have to observe before you explain. Number two, a truly intelligent system must be able to tolerate uncertainty, not just rush to eliminate it. And finally, number six, just because something is quiet, that doesn't mean it's gone or that it's failed.
When we finally unchain our idea of intelligence from our own short lifespans and our planetary biases, it doesn't get louder or faster. It gets quieter, more patient, more deeply woven into the very fabric of matter. At that point, intelligence and the universe aren't really two separate things anymore.
And that leaves us with one last, pretty humbling question to think about. If the cosmos is actually humming with a quiet, patient, persistent intelligence that's so advanced it's materially invisible to us, what does that say about our own noisy, fleeting, and fragile place in it all?